section 6.4, I can use the triangle inequality theorems. So our first theorem for today is if one side of a triangle is longer than a second side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, so in other words, if I have triangle ABC, and I know that BC has a length of 26 and AC has a length of 24, well, then I know that angle A has to be greater than angle B, because angle A is opposite the longest side. Okay, so angle A, measure of angle A, has to be greater than measure of angle B. And then there are a couple corollaries that go with this. Well, let's do the converse first. Okay, the converse says if one angle of a triangle is larger than a second angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Okay, so in this one, if measure of angle A is greater than measure of angle B, still using this same picture from above. So this is A, B, C. And we know that this angle is greater than this angle. Then we know that segment BC is greater than segment CA. Okay? Alright, and then corollary 1, the perpendicular segment from a point to a line is the shortest segment from the point to the line. Okay? So the distance from here to here, the shortest distance is the perpendicular segment. Okay? Corollary 2. Okay? And it says the perpendicular segment from a point to a plane is the shortest segment from a point to a plane. Okay? And then that brings us to our final theorem, and this one has a name. It's called the triangle inequality theorem. Okay? And it says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, this is a very, very important theorem. We're going to use it quite often. And it just says that if you have a triangle A, B, C, then the length of AB plus the length of BC has to be greater than the length of AC. Okay, and that's true for any two sides that you pick. So the length of BC plus the length of AC has to be greater than the length of AB. Okay, and then if you have the length of AC plus the length of AB, that has to be greater than the length of BC. Okay, and this is used to determine whether three lengths can form a triangle. Okay, it's one of the ways that we check it. All right, let's look at some examples. Okay, so if I give you this triangle A, B, A, B, C, and this is 15, this is 16, this is 17. Which angle has to be the greatest? Angle B would have to be greatest because it's opposite the longest side. And which angle would have to be the smallest? Angle C, because it's opposite the shortest side. Okay? So example 2. If I have this triangle, where this is D, E, F, and this is angle 10, this side is 10, this side is 10, which angle would be the largest here? Okay. Well, if we know this is 14, then this angle would have to be the largest. So angle E would have to be the largest angle. Okay. Example 3. If I had this triangle, and I knew this angle was 65, this angle was 70, so that's 135. So this angle would have to be 45, okay? Then which side would have to be the longest side? Well, BC would be the longest, and AB would have to be the shortest because it's opposite the smallest angle. Okay. Example 4. If I gave you the lengths 9, 6, and 2, is it possible for those to be the sides of a triangle? Is that possible? Okay. Well, remember the triangle inequality theorem says that the sum of any two sides must be greater than the third side. So if you have 9 plus 6, that's greater than 2. But if you have 6 plus 2, is that greater than 9? No, it's not. So it's not possible for those three values to be the sides of a triangle. Number 5. If two sides of a triangle have lengths 8 and 12, then the length of the third side must be between what and what? Okay? Well, the third side has to be greater than 12 minus 8, or 4. But it has to be less than 12 plus 8, or 20. Okay? So the fourth side must be between 4 and 20, because that would give you a value where the sum of any two sides would be greater than the third side.